This week's lesson is aimed at introducing to your second virtual field trip. Just to review, it's assignment number 3. You're going to need to open up the spreadsheet that goes with this particular assignment. And you should have found that in the Google Classroom. You should also, prior to starting, and you can pause the video now if you want, have opened up the tab sheet which I'm looking at here. And you want to have Google Earth open if you can, because we're going to be using that. And you also want to go to Digimaps for the first time, which is a Ordnance Survey map tool for the whole of the United Kingdom. So to get that open, first time you open it, you should go into the RM Unified tiles, and if you scroll down, you should find this tile called Digimaps tool. When you click on that, you need to enter the username and the password that are there into that, and then it will allow you into that particular piece of software. Right, today I'd like you to type the heading stream analysis into your virtual jotter, and that's what today's fieldwork is going to be about. It's going to be focused on conducting a virtual field study based on a river study, or what we call a stream analysis. Now, like all fieldwork, I've got this little introduction written here that you will have probably already read. When you do a study, you have to first of all think about what it is you're investigating. Okay, so in this case, this would be a field study that involved a river at the center of the investigation. Now, rivers can be and have been studied in many different ways by students over the years. And the simplest method, I suppose, or river study you actually did as part of your hire, which was a downstream river investigation of a river called the Amity Burn. And in that, you were quite simply looking at how different characteristics of a river changed. And you all students looked at the discharge, which was the volume of water passing every second, at 10 or so sites. And therefore, the idea was you were going to investigate how that discharge changed as you moved further down the river. And then you picked a second characteristic or variable of that river to see how it changed. Now, that's quite an easy study, and in this case, or in the case of your higher investigation, you were looking to see about how features of the river and more importantly how the landscape around that river might have influenced those changing characteristics. You also thought about how the geology over which the river flowed might affect the characteristics, how different land uses, whether it was in an urban area or the countryside, and so on. Right, so that's the first kind of key aspect of today's lesson. That's what we're investigating. We're thinking about how we're planning on analyzing a stream. Second thing is we're going to start to think about, okay, if the river is the center of our investigation, what other aspects could I study? And one of the other key areas of your course was that you learned about different factors that influenced a river when it rained. And you might remember looking at storm hydrographs, which were special graphs that showed what happened when it rained to the discharge of a river, and the fact that a river starts to rise, or its discharge starts to rise when it rains, and the discharge falls when it stops raining. But the speed of the river rise, or what's called the rising limb, was affected by a range of factors to do with the surrounding landscape. Likewise, the actual height that the discharge got to, so that's the height of the river, I suppose, is the best way of describing that, is also affected by the surrounding landscape. So for example, if you've got lots of trees around your river, and not just around the river, but actually in the whole surrounding landscape in the river's drainage basin, then you would expect the trees to intercept a huge amount of water coming out of the sky and absorb that rainwater, and therefore the river itself would not get as much water as it would do if you were to cut all those trees down. And we also looked at other things like, how would an urban landscape, if you were to tarmac the entire landscape, how would that affect a river? Well, clearly, because a tarmac landscape doesn't absorb any water, and the water quickly flows to a river when it falls onto a city or onto tarmac, a river you'd expect it to rise really quickly in those circumstances, and it would probably reach a huge peak, and that's because there's nothing storing or holding onto the water. Okay, so we're going to bring those ideas together in this particular virtual field study. And the first thing I'm going to ask you to do is to read a stream analysis field study, which is in your virtual textbook. And if you open up that virtual textbook to page 26 and just have a read through what actually is a stream analysis, I'm just waiting for it to up here. And it will give you a rationale for conducting this kind of study. Now, a rationale is a reason to do something. And in your own geography projects, the very first thing you write in your introduction is going to be your rationale. An introduction to a project is always, the rationale for conducting a project. That's not really loading up, so I'm just going to jump back. I'll let you do the reading on that yourself rather than letting it load up. So once you've done the reading, you'll see that it talks a little bit about how you gather the data. It explores the idea of sampling again, which is something we looked at a couple of weeks ago in our St Andrews virtual field trip. And it'll look at also how to present data. And you'll be introduced to this idea of geolocating data, which is where you put your data onto a map. You present your graphs or your pictures on a map, and that map could be an Ordnance Survey map, or it could be a map that you've got from Google Earth. Okay. And once you've watched your first, once you've completed this kind of little introduction, so you've got a little task here, which is where you need to think about 3 pieces of data that you could investigate about a river. Okay, so if you were doing a stream study like we did on the Burn, then what 3 aspects of the river could you study? And sometimes it's important to think about not just studying the stream itself, but gathering data on the surrounding land and the drainage basin, because if you don't have that data, it becomes difficult to try to predict how and why the river's changing. And stream analysis don't have to just be one river like we did at Higher. You could do 2 and compare them. I actually had an advanced high student this year doing such a project where they compared a river that flowed through a town versus a river that flowed through a farming landscape. A couple of years ago, I had a student look at a river that started life at a dam, and therefore its flow was controlled by the dam itself. And they looked at how that was influencing the characteristics of the river, its pebbles and so on, versus the characteristics of a natural river that didn't have a dam. So stream analysis don't have to just be locked in the one we did in the Burn. There's all kinds of different variations of this. And what influences the type of study you end up doing if it was a river study would be the actual data you're gathering. So you've got to think about what 3 bits of data would I want to gather? And when you describe them, you might want to give a reason for gathering those bits of data. If you're going to go with maybe one of them being discharge, you'll have to think about, if you're going to find out the discharge of a river, what data from the river we need to measure discharge, because there are different variables that go into discharge. The next step is to do a little bit of background research, and all geography projects require this step. And I've got an explanation for why we do this. The main reason, obviously, for any background research is it gives us background information for what other people have discovered doing similar investigations. So what have researchers or other geographers or scientists found out about that which we are studying? Because inevitably, nothing we do is unique, and everything we do and everything we study, by and large, has been studied by someone else before. I mean, let's just take the current outbreak of COVID-19. Okay, it's a brand new disease, so nobody studying that has ever studied that virus before. But huge numbers of people have studied viruses and how they spread, and factors that can be used to limit their spread and so on. So by studying viruses, we were able to compare the new virus with pre-existing viruses. Likewise, if we're studying a river in this case, and why its discharge might change, we could look at people who have done work on other rivers to find out what affected their discharge. And that would then allow us to compare the river we're studying to other people's work. So I've got a little question here, which is, I'd like you to research and give me 4 explanations of possible factors to do with the surrounding landscape. And that could be the relief, the drainage basin, the geology, anything to do with the landscape. And you can do both, land uses. So you might be wanting to tell me how forestry, or how an urban landscape, or how an agricultural landscape that was surrounding a river could influence a characteristic of a river. And by characteristic, I mean anything. If you've decided to gather data on discharge, you would then be telling me how these things would affect discharge. If it was rock size or rock shape or the efficiency of the channel or anything like that, you would be wanting to tell me how they might affect that characteristic. Okay. I'd then like you to read this little bit here. Write methodology, and that step of any virtual project and real project, which is what you're all going to have to do, is the step where you tell us where you're going to gather your data and how you're going to do it. Now, in today's tutorial in our virtual fieldwork, I'm going to be asking you to select a river. In this case, it's going to be the Almond, or the Almond if you're American. And you're going to have to extract an Ordnance Survey map for your field study area. Now, all geographers need to use maps to show where they are doing their field work. And on top of that, they then normally would have to show on those maps the actual sites on the map that they are going to visit, which is what this task involves. So you'll need to watch this little video, which is going to tell you how to get hold of an Ordnance Survey map. And then the task after that is actually linked to getting that map from Digimaps and then adding some features to it. Now, the tutorial will show you exactly how to do everything to get hold of the map, and then how to manipulate it in Google Docs using the draw facility. So at this stage, what you might want to do is just read through these instructions, watch this tutorial, pause obviously my main lesson video, and then come back to me once you've completed that sort of first step, and we can move on. Okay, once you've done your background research, you've got your map, you have described the distribution of your sites, I'd now like you to tell me a little bit about your actual sites. So you'll have selected them, and you will have had a reason, a sampling reason for selecting the spread of sites. And you'll have given me a couple of explanations, or I'm hoping you have. You're now actually visiting those sites. Now, the great thing about the world we live in today is we don't need to get in a car and visit sites in advance. When I was your age, I had to do scouting my locations before I would even gather my data and decide suitability. I'd have to conduct detailed risk assessments, whether they were safe to visit or not. And then inevitably, I'd have to go out there with my equipment and gather field data. In this day and age, you can do a little bit of the work beforehand by using Google Earth and the Street View facility. Now, Street View doesn't work for everything, especially if you don't have any roads nearby. And that's the problem with rivers. Rivers obviously often don't have roads. So that you might be limited by the actual type of study you're doing and where it is. But it's amazing how much of Google Earth is covered with 360 views of the world's landscape. So if you watch this little tutorial, it's going to talk about how to use the Street View function. It's going to ask you to get a photograph from the bridge where you're starting your field study, and a photograph from the bridge where you're finishing your field study. And those are both indicated in the previous tutorial or on the Ordnance Survey map. And you're going to have to find a photo of each of those, and you're then going to have to add some information to those photos, which I've outlined here. And that's to do with something you notice in the photo that might influence or affect your ability to gather data, whether that's a positive or a negative aspect. I mean, for example, if you notice there's parking available near where you're going to study it, well, that's an advantage. If you notice there's really steep riverbanks with huge amounts of bushes, or the river's really deep, then that might be a limiting factor for you conducting field research at that location. So I'd like you to complete that task. The second task is to actually find a couple of images from the surrounding landscape around the River Almond, drop in using the Street View function, take a screenshot of those photos, and then add a piece of information or annotate image with something that tells me about what the land use is and how that might affect the river. So if you, for example, dropped into the Inver Almond Industrial Estate, which is an industrial estate that lies to the south of River Almond, and you'll see that on your Ordnance Survey map and on Google Earth, then you might decide to pop a photo of that industrial estate into your jotter and then add a label or an annotation, which is a detailed description that says, water landing on this region is unlikely to infiltrate and be absorbed and therefore flow quickly to the river, increasing the discharge. And that's just giving you an example of an annotation you might add to a photo if it was of of an urban landscape like the environment industrial estate. Right, moving on with today's lesson. We've now got our data. We've selected our sites. We're now going to gather a bit of data. And in this, my third tutorial is how to gather data on the amount of each of the different land uses that surround the river. And that's assuming maybe we were doing our field study where we were looking for the relationship between the quantity of land use and how the river changes in terms of its characteristics. And in all likelihood, one of those characteristics will be the discharge. So if this was a real field study, we would probably start at our first bridge in Bank, and we would walk along the left-hand riverbank all the way to our endpoint with a trundle wheel, recording how many meters of forestry was around our river, how many meters of farmland surrounded our river, how many meters of urban, and so on. And that would take quite a long time. Depends how long our river is, I guess. What we can do, though, is we can shortcut that in Google Earth for our virtual field trip today. If you watch this tutorial, it will show you how to gather the distance for 3 different land uses using the measure tool in Google Earth, and then have to enter that into a table. And that's what you need the Google Sheet for. So you'll find that's been attached to this week's lesson. Enter your data into the Google Sheet, and it's going to then show you how to create some pie charts. And then if you have a look at the task, you're going to have to write findings. You're going to have to create those pie charts. You're going to have to put those pie charts onto either a Google Earth image or the Ordnance Survey map, which is the one I show you in the tutorial, and then put it into your project. So that's what we call geolocating data. Okay. You're then going to have to, down here, write a little paragraph that compares the amount of land use on the 2 different sites. And that's just comparing. So is there more of one than another? And you should be using the data in the pie charts to allow you to do a bit of analysis. And then finally, you've got an explain question here, which is where you've got to use your evidence from the pie chart, how you think your river will change when it rains. So using real data now that you've gathered, not theoretical things that could affect a river, but the real data you've gathered, do you think that when it rains that the surrounding landscape is likely to have a major difference on how water gets to the river or not? So if you've discovered that the surrounding landscape has got a lot of capacity to store water and intercept it, then you're probably going to be saying that when it rains, actually, the river will not probably rise to a very high peak, and it will probably rise quite slowly. Whereas in contrast, if your results suggest that you've got quite a lot of urban land use around your river at this stage, you're probably going to be telling me that that's going to have a major influence on the river, and when it rains, it's going to rise, have a really steep rising limb and a very high peak. Okay, so whatever you write, it'll be based on the evidence from your 2 pie charts. Okay, and then just to finish off, I've got a little exam style question, which is a sort of typical question that you see where the example doesn't actually tell you about what techniques they want you to discuss. They just say, discuss a suitable technique you could use to present and analyze your field data. And they'll give you a context. So your context in this would be a stream study. So what you might then do if you saw this question is you might think, if I was to do a stream study, I might look at downstream changes from the beginning to the end of the river. And I could use the geolocating technique and use pie charts. So what do I need to do? I need to explain why pie charts are a good way of presenting data. And that deals with this first little part of the question, which is how do you present your data? And then if I geolocated it, I could then explain to the marker how geolocating my data would help me analyze my results. So actually interpret my results. Because if I'm putting my pie charts on a map, I can use information from the map to help me understand my results better. So I've given you a little bit of kind of into what you would write. Obviously, you wouldn't see any of this stuff in an exam question. That's just guidance I'm giving you based on today's lesson. Okay, so reason for this long lesson is this is actually, you've got quite a bit of time to play around with this. You've got till Thursday, the 21st of May, because I think the tasks are going to take a bit of time. You also have had some work set by Mr. Anderson, and he's starting to move you into some more advanced sort of skills and techniques in terms of analyzing texts for your essay. So you're going to have spent a bit of time on that too. So that's why I'm giving you a little bit more time to work on the tasks.